Hi friends, today we are going to see how to use the direct form 1 realization structure in solving a given problem. The problem for today is stated as obtain a direct form 1 realization of a system described by, and the system is given as y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 equal to x of n plus 1 by 3 x of n minus 1. So now this is what the realization is given, or this is what the system is given by. This is called as a difference equation. So this is my given difference equation. So whenever they wanted me to put a realization form, they will actually give me a difference equation. Okay, this is a difference equation. Now from the difference equation, I need to first find in terms of, I need to actually get h of z, because we actually wanted to solve this h of z as two subsystems, which we called as h1 of z into h2 of z, and h1 of z will be w of z by x of z, and h2 of z will be y of z by w of z. Okay, so I will be having a system which is comprises of two subsystems. One will have x components and the other will have the y components, and y of z is a dummy variable or a dummy node. We called it as y of z as a dummy variable. Okay, so to get h of z, first I need to apply the z transform on a given difference equation. So always whenever a problem is given and the starting of the problem is with difference equation, step 1 will be using z transform. So I'll be always using z transform to get my h of z. So if I apply z transform, then y of n will be y of z minus 3 by 4 constant, then I have y of n minus 1. So n minus 1, so I will write z inverse into y of z plus 1 by 8 z y of n minus 2. So I will multiply y of z by z raised to minus 2, which is all equal to x of n will be written as x of z plus 1 by 3 z inverse x of z. To obtain h of z, I will take common x of z from here and y of z from here. So it will be y of z into 1 minus 3 by 4 z inverse plus 1 by 8 z raised to minus 2 equals to x of z into 1 plus 1 by 3 z raised to minus 1. Okay, now h of z is nothing but y of z upon x of z. So my h of z will be equal to y of z upon x of z. So I will bring x of z in the denominator this side, and I will take this term in the denominator on the other side of the equal to sign, which will be 1 plus 1 by 3 z inverse divided by 1 minus 3 by 4 z raised to minus 1 plus 1 by 8 z raised to minus 2. Okay, so this is what my h of z is. Now normally we will be dividing the system, as we know that this terms belongs to x of z. So they will form one system which is h1 of z, and 1 upon this terms forms y of z. So that will form h2 of z. So h1 of z will have this terms and h2 of z will have this terms. Now let us not derive the things completely, because in a given problem there is no much weightage so that you have to derive it. We will directly draw the structure. So I will write h of z again and I will draw the structure and give some hints that how you can directly get the structure. So let us say that this is my given transfer function. Now with this h of z, what we will do is I will give this names as numerator polynomial, I will give name as a0 a1, the coefficient name as a0 a1. Denominator polynomial, the names as b0 b1 and b2. Okay, some textbooks refers in the reverse order. They refer b0 b1 b2 for the numerator and a0 a1 a2 and so on to the denominator. So whichever you wanted to use, it is they are just a representation. So all my a's which are in the numerator, okay, will be going in the forward direction, and whichever are in the denominator will be coming in the backward direction. So for direct form 1, okay, so we are actually going with direct form 1, which is also written as df1. Now you see that there are z raised to minus 2 terms in the denominator. So what I will do is I will draw 2 lines of z inverse terms. So this is my one of my z inverse term, this is the second z inverse term, and I will draw one more line on this side, because here there is only one z inverse term, so I will write only one z inverse. There are z raised to minus 2, so I have written 2 terms. Now associate with z raised to minus 1, we will go back. While going back, the denominator coefficients will always be back. Now with respect to z inverse, the term that is present is minus 3 by 4, so I will write plus 3 by 4. So whenever you go back, you have to reverse the sign of the coefficient. Then when I come back from here, it will be plus 1.8, because that is with z raised to minus 2. This term is z raised to minus 2. So instead of plus 1.8, I will change the sign and I will write as minus 1 by 8. Okay. Then I have 1 in the first place. Now I need to add them all. So if I add this, I will put an adder. So I will add these coefficients. Okay. So now what we have received is, we have here, okay, and let us take this. This is the flow graph, or this is this will be my flow, and this is my y of n. So y of n will be coming in this block and becomes y of n minus 1. Then it will go further and becomes y of n minus 2, which is equivalent to, okay, z inverse y of z, and which is equivalent to also z raised to minus 2 y of z. So this is how the denominator part is over. Now let us go to the numerator part. In the numerator part, I have drawn one z inverse term, which is having a coefficient of, if there is plus in the numerator, then you will not change the sign. Okay, so you will change the sign if the coefficients are in the denominator. So all denominator coefficient sign must be changed. And here I will keep a line, the flow will be like this, and here I will write it as x of n. Of course here it will be x of n minus 1, which is equivalent to z inverse x of z. And with that I have 1 by 3, which is plus again, and then it is added with 1. So I'll add with 1, and then I'll attach them both. So this system which you see on this side which contains the numerator polynomial is h1 of z. Now this is h1 of z, and this section is my h2 of z. And when I multiply h1 of and I connect them in cascade, that time I will write it as h1 of z into h2 of z. That time the whole process will be h of z. So the complete process is h of z, but here I get half section as h1 of z and this is h2 of z. So now just to summarize the point, what we will do always is the numerator coefficients will be going in the forward direction. So it is like 1 and they will be going in the forward direction. There will be no sign change in the numerator coefficient. The denominator coefficient will be always coming backwards, and there will always be a sign change in the of the coefficients. So in this way we form a direct form 1 realization. Just to generalize the problem or just to generalize the system, we can write in general as if h of z is, let's say, a0 plus a1 z inverse plus a2 z raised to minus 2 plus so on plus a, let's say, n z raised to minus n divided by b0 plus b1 z raised to minus 1 plus b2 z raised to minus 2 plus so on till bm z raised to minus m, and m and n are, let's say, not equal. Then how will I draw? I will draw a series of z inverses. So for the numerator I will draw on the left hand side. Okay, it will be like z inverse z raised to minus 2, z raised to minus 3 and so on till z raised to minus n. The flow will be given from x of n, and then I will have adders in between. Okay, so one input will come from some blocks ahead. Okay, and for the denominator polynomial I will draw an adder first. Let's say you can draw the same way as you have drawn the other side. That means z inverse first and then the adders. You can draw it likewise also. So I have to draw again a string of z inverse, okay, and a stream of adders, and then I will add the coefficients. Okay, so this will go like this, right? Then when I add the coefficient on this side, this will be a0, okay, this will be this side. When it is going in this side, this will be a1, this will be a2 and so on and so forth, it will be an. Okay, so all the coefficient will have the same sign. Let's say a0, a1, a2, an all are positive, then I will keep all positive. If they all are negative, I will keep all of them as negative. If any one is negative and the rest are positive, then the negative will retain with the negative sign and the positive will retain the positive sign. So no sign change in the numerator polynomial. In the denominator polynomial, whereas this is my b0 which goes in forward direction, rest everyone comes backward direction. Okay, you have this minus b1, minus b2 and minus bm. Now because I have consistently used plus in the polynomial, I am using consistently minus over here. So you have to change the sign of the denominator polynomial coefficient. So whatever coefficients you write, you have to change their sign and write the coefficient when you are writing the denominator polynomial. Denominator polynomial will be coming backwards, numerator polynomial will be going forward direction, and then connect them both. Here you get the output from y of n. So this is y of n. Okay, so this is what the general form of direct form 1 structure is. Thank you.